2011 was an exciting year for astronomers. For over 200 years, mankind has known about the existence of gigantic asteroids found in the asteroid belt, but for most of that, they've only been specks in the night sky. The first asteroid to be discovered, Ceres, was found in 1801 and was added to the list of planets. A year later, Pallas was discovered, and in the following years, Juno and then Vesta. Because of this, in 1845, our solar system had 11 planets, the original 7 from Mercury to Uranus, as Neptune hadn't been discovered yet, plus the 4 asteroids. As more and more asteroids were discovered, it became clear that they couldn't all be listed as planets. A good thing too, as today there are millions of known asteroids of various shapes and sizes. However, before 2011, we had never seen any of the original 4 asteroids up close. Enter the Dawn spacecraft. Launched in 2007, it had a very special mission to explore and investigate not just one, but 2 of these large asteroids. First Vesta and then Ceres. But what did it find and discover while it was there? Part Ceres, we'll find out everything Dawn saw and discovered around the asteroid Vesta. The first thing you'll notice about Vesta is that it has an unusual shape. It kind of looks like a squashed ball. There are 2 reasons for this. The first is that it is not very big. Yes, these asteroids, although big for asteroids, are pretty tiny on astronomical scales. Vesta is not quite big enough for it to be in hydrostatic equilibrium, or in other words, to be rounded by its own gravity, as it is only about 500 kilometers in diameter. This gives it the surface area of Pakistan, about 800,000 square kilometers. You'll see how small it is if you compare it to our moon. Although, it should be noted that even at this size, it still contributes towards 9% of the total mass of the asteroid belt, which can help you appreciate just how dispersed the asteroid belt really is. The second reason for this unusual shape are the 2 giant impacts it experienced in its past. Estimated to have occurred over 1 billion years ago, Vesta was impacted not once, but twice around its south pole with planetary scale objects. These impacts produced craters so large, they penetrated all the way to the mantle of the asteroid. The crust has since cooled off and solidified, leaving a complex crater called Rhea Silvia. As these craters have overlapped, Rhea Silvia is the most recent and thus the most prominent crater that remains. As is typical with complex craters, terraced walls can be seen around the edge of the crater, seen in the form of huge troughs around the equator that put the Grand Canyon to shame in terms of size. Also typical of complex craters, a prominent peak can be found at the center. This peak was once thought to be the tallest mountain in the solar system, but more accurate dawn observations show that the title has returned to Olympus Mons. Although Rhea Silvia is still 20 to 25 kilometers high and over 100 kilometers across. Due to its size compared to the size of Vesta, it appears like a giant pimple around the South Pole, and it is easily visible from orbit. The 2 collisions that carved out the South Pole of Vesta flung a massive amount of ejecta into space. So much debris ended up in the asteroid belt that the debris has been given its own asteroid spectral type classification, namely V-type asteroids. V-type asteroids are thought to have originated from Vesta, and a lot of them can be traced back to those impacts. But these asteroids didn't just end up in the asteroid belt, they are scattered all across the solar system, and in fact, 5% of the meteorites that end up on Earth come from Vesta, known as Howardite, Eucrite, Diogenite meteorites. This is very handy, as we haven't needed a sample return mission to be able to study samples of Vesta, because Vesta has delivered some right to our front door. Their structure and composition reveal some clues about how Vesta was formed, and the Dawn mission attempted to broaden that understanding. From a combination of all the data collected, it has been revealed that Vesta is very unique in our solar system. it is the only remaining rocky protoplanet, or in other words, it is a planetary embryo that never finished forming. The theory goes that as the solar system was forming, dust from the early protoplanetary disk coalesced into thousands of different planetesimals. These planetesimals collided with each other over time, building up into the large planets we see today. Our moon is thought to have formed from such an impact, with a large planetesimal impacting Earth, called Theia. The debris from the collision coalescing in Earth's orbit, and over time rounding under its own gravity to form the moon we know today. Vesta obviously got started on its way to becoming a planet. It experienced plenty of large impacts with planetesimals. As a result of all these impacts, the heat generated by them meant that at one point Vesta had an active mantle under the surface. Even today it is believed to still have a core of iron about 220 kilometers in diameter, a core similar to the other terrestrial worlds like Mercury, Venus, Earth and Mars. However, Vesta's interior has since cooled off, meaning the interior has solidified. But because of this differentiated interior, it likely would be called a dwarf planet today, if not for those two collisions we talked about earlier. One of the criteria for a dwarf planet is that it is rounded under its own gravity. But as the collisions happened roughly 1 billion years ago, a few billion years after Vesta formed, Vesta had already cooled off too much for it to be elastic enough to return to a shape in hydrostatic equilibrium. And the reason Vesta never became a planet? Fingers are currently being pointed at Jupiter, which stole mass that would have otherwise formed Vesta, or at least disturbed enough of it to stop Vesta from ever getting going. Now, to the naked eye, Vesta does appear quite bland. This is a true color image of Vesta, appearing as you would see it. However, if you have a camera that can see in a wide variety of wavelengths of light, suddenly Vesta's true variety becomes apparent. In this composite image, the black material is likely ejecta brought by a large meteor impact. The red material is likely also from an impact, but is material that melted before solidifying again. Dawn also made some unexpected discoveries on Vesta's surface. Vesta is thought to be very dry, with little to no volatiles found in its crust. Why then has evidence of past flowing been observed? In this false color image, you can see a crater a couple of kilometers across, with a flow channel coming out of it, the different colors indicating it consists of a different material to the surrounding area. The exact origin of this material is unknown, but perhaps it was brought by the impactor and melted on collision. Another fascinating discovery was found in one of Vesta's young craters, Marcia. Near the bottom of the crater, Dawn observed something called pitted terrain. Why pitted terrain was found on Vesta is a bit of a mystery, as we have only seen it on Mars before that. However, scientists believe hydrated mineral rocks on the surface may have been rapidly heated, perhaps by another impact, releasing the water in the rocks, which exploded as the water degassed into space, leaving these craters you see here. And I would be remiss to mention that this Marcia crater is part of a chain of craters which makes up the famous snowman found on Vesta. What is interesting though is if you notice the terrain is relatively smooth around these craters. This is believed to be because a blanket of ejecta covered the region from the impacts, smoothing it over. Dawn was only around Vesta for a year before it left Vesta's orbit and moved on to the second leg of its journey towards the actual dwarf planet, Ceres. As a result, Dawn is the first spacecraft to have orbited 2 extraterrestrial bodies, and this is thanks to Vesta's weak gravity and Dawn's amazing ion engine. Although slow, it took 4 days for it to accelerate from roughly 0 to 100 kilometers per hour. Over the course of its mission, it was able to perform a velocity change of 11.5 kilometers a second, beating the previous record by 2.7 times for a spacecraft that had separated from its launch craft. Dawn finally arrived at Ceres in 2015, but we will save that for next time. So there we have it, a summary of everything Dawn saw and discovered around Vesta. Ever wonder about the physics